Howdy! This video will illustrate our senior design project experience. Dr. Hasnain and Dr. Sarah Polly have sponsored this four-wheel independent steering and drive system. Consisting of a chassis team, being us, and a software team, this project seeks to develop a prototype for a more efficient form of transportation. The definition of a four-wheel independent steering and drive system is where all wheels can move at different speeds and turn at different angles independently of each other. Eventually, the vehicle will be autonomous and reach all the following requirements. The first part of any design process is generating concepts to meet the customer's needs. A few examples of proposed ideas are seen here. The standard golf cart design would be one of the most easy to implement options, while the Schaeffler and collapsible canopy offer a more complex design with comfort holding a higher priority. The design my team and I presented at the end of our first semester is seen here. The top of the vehicle has two roller shades that can be extended forward towards the front of the vehicle to provide shade inside the cabin, and down the back to block sun from behind. After returning in the latter semester, Dr. Sarah Polly had purchased a new, integrated steering and drive wheel that could be mounted to the vehicle. As a result, the system required a redesign of the chassis. To compensate for the amount of time required in the redesign, the canopy and cabin of the vehicle would be stripped to meet time constraints. Here is our new, already integrated steering and drive motor, the Allied Motion Wheel Max 5097. This new system can turn 105 degrees both left and right, giving a large range of motion. Although this solved many issues, the new motors have a top speed of 3 miles per hour and have little ground clearance. The following finite element analysis highlights the new, redesigned chassis. Using aluminum 6061 for the entire system, both a strong and lightweight design have been assured. The factor of safety for this system came out to 11.35 for static load condition. When accounting for dynamic loading of the vehicle, the applied forces were assumed to be an order of magnitude higher, causing our factor of safety to be 1.135. In order to check the quality of the welds done by the FEDC, destructive tests were done at the Transportation Testing Institute, located at Texas A&M's Rellis campus. These tests consisted of a bending moment for the elbow joint along the chassis side rails and a tensile test for the subassembly's vertical strut. The results have been tabulated here, and both the joints performed admirably. The failure load to beat was 5 kips, and all the samples passed the experiment. This gave our team a great deal of confidence in having the FEDC weld our system together. As mentioned earlier with the new motors, there was little to no ground clearance, and the top speed was 3 miles per hour. In order to fix these issues, multiple wheel connection methods were considered. One possibility was a hard case that would bolt around the motor, while the others implemented various gear systems. The team decided on the 2 gears wheel connection. Using the 2 gears coupled with a larger wheel, the system could increase the speed of the vehicle by 100 to 150%. The whole system would be made out of 1015 cold rolled steel, and it passed the FEA with a 1.5 factor of safety. Unfortunately, due to time constraints, the material to fabricate the cage could not be ordered in time, and testing for maneuverability had to be conducted on the original 6-inch diameter wheels. Here, the vehicle could be seen during operation. The capabilities include forward, back, and left-right translations, in addition to a 0 radius turn. The vehicle performed all maneuvers with minimum deviations, thus resulting in a successful series of tests. Lastly, future work for the project includes the implementation of a larger wheel connection to boost the vehicle's speed, the addition of a canopy and cabin to provide a more comfortable ride, and a boost to the aesthetics of the vehicle to make it more pleasing. We appreciate you taking the time to watch our senior design project experience. Thanks, and Gig'em.